All right, so let's pick up where we left off. Entering variables. Okay, so we're going to do A over here. So we'll go A times. Now, this is a situation again where the 84 is able to do implicit multiplication, but the 89 is not, meaning you could write AB and it'll interpret it as A times B. The 89, if you wrote AB, will interpret it as the variable AB. So just keep that in mind. I'm going to do explicit multiplication signs here just to have the clarity. 3 times D times, then we can go E to the 4th. And there we go. So that's going to be our answer. Now, another thing that you might not be aware of is, let's say, you're going to see me do it now, but let's say that I made a mistake. Maybe it was to the 5th. Well, what I can do is I can press the up arrow, go back to my previous entry, press enter, and it's going to bring it back down, and I can edit my entry and then press enter again and get the that different answer. Or let's say that I need to take that answer and do something with it. Again, I can press the up arrow to find the answer. Then maybe I need to divide it by 4, so I can press divide by 4. And so I have quick access to those numbers in this list and entries without having to, again, type them in manually. So it's all about time saving, and especially on the multiple choice, the more fluid and quickly you can use your calculator, the more time you have to think and work through the problem. So it's a huge advantage. Okay, let's move on to something else. So let's do a little bit of function graphing. I'm going to kind of break away from the examples that are given here in the notes. If you find yourself having trouble using the calculator or you just don't feel comfortable with it, take the time to really read through the notes and work through the examples they're showing, using your calculator as you read through. So, all right, we'll put in this linear function here that they've got, 3x minus 4. We'll press enter. And I'm just going to press graph, and we might not get a very good graph of what we wanted. So in this case, this is not a great graph or a great viewing window because we can't see the y-intercept. So we're not getting all the important information that we need. So we need to zoom. Now, our first option is we could zoom in or zoom out. So we could press zoom out. It's going to zoom out from the point that the cursor is at. So maybe we want to zoom out at the origin or somewhere else. All right. Yeah. And that might give us a better graph. Now, here's something else to keep in mind. The steepness of the slope, or the roundness of a curve, is determined by your viewing window. And notice that your calculator has a aspect ratio that is not a square. So if we want to view something and really know how steep something is or how round something is, we need to make sure that the viewing window is square. So we can go to zoom and we can select square, and that's going to make sure that the viewing window is displaying the horizontal and vertical line segments with even representation. Now, let me show you what could happen. Let's say we pick a window that is not doing that. So we're going to go from negative 100 to 100. So I'm changing the window manually. I pressed window. This is my minimum x-axis value, my maximum x-axis value. This is how much to go between each notch in my axis. And then the same thing for the y. So we'll move by 5s, and let's see how that changes the graph, or at least the way the graph looks. So you can see that now with this new viewing window, the line looks to have a very large slope. It's almost vertical. But it's because we've picked a viewing window that is not really appropriately showing us the slope. And again, we could have the same thing with a circle, where a circle is going to end up looking like an ellipse, be stretched out along one axis. So again, we can set it by doing z square. That's going to give us a better idea of how steep the slope of this line is. So there we go. We can see it's not quite as vertical as we were thinking. Now, another really important thing here, if you're having trouble figuring out what the viewing window should be, a good place to start is with zoom fit. Down here, zoom fit is going to try to look at the function and figure out what is a good viewing window. Now you can see it's altered the horizontal and vertical axis, so we get a line that looks like it's at 45 degrees when in actuality it's a little bit steeper than that. So just keep that in mind, but at least we can see certain things. Now, we're not really seeing the horizontal or vertical intercepts very well. In this window, it looks like it's going through the origin. You need to get into the habit of, whenever you graph a function, zoom in, zoom out, look at it in many different ways, because it's very easy to look at that graph and think, oh, it goes through the origin. But we know that no, this function does not pass through the origin just by looking at it. So we're going to zoom in near where we think is an important characteristic of this graph. Might need to zoom in again. So I've really messed up this graph because of the way the viewing window was. So one way we can reset it is we can go to Z standard. That's going to give us the default graph. And then there we go. So that looks real nice. And then if we need to, we can zoom out or zoom in, or we could again go back to Z square. Now Z trig is a good good step if I'm graphing a trig function like a sine wave or a cosine wave. Anyway, okay, let's go back. Let's enter a new function. So in this case, let's do x squared. Oops. We're going to do x squared minus 5. We'll go back and graph that, see if it gives us everything we want. So that looks pretty good. And again, we can see some of the interesting bits. We can see intersections between the two graphs. And we can see there's zeros and that kind of thing. A couple options we have is, let's say that we don't want to get rid of this function, but we don't want it to be graphed anymore because we've moved on to a section of the problem that only uses the first graph. What we can do is we can press the over arrow, enter, and you see how the equal sign is no longer inside a black box. That means we've turned that graph off. So when we go to the graph, it's only going to graph the line. It won't graph the parabola. So that's going to save us a lot of time. We can turn the graph off when we don't need it. And then if we need it again for a later section in the problem, we can turn it back on and go ahead and see both graphs again. So that's very useful. Another thing that we can do is we can change, if you have the color version of the TID4, then you can change the colors, or you could change the way the line is graphed if you have two graphs that are hard to tell apart from each other. So we can let me go back and show you how I've done this. So we're going to press the over arrow so we get all the way over to the left, and then press enter, and then we can change the color if you have the color edition of the TID4, and we can change the type of line. So we could, I'll show you what those mean later, we can change it to graph into a dotted line or a thinner line to make them easier to tell apart from each other. So I'm going to switch to this dotted line. I'm going to press enter, OK, and then let's see what that looks like now. There we go. So we can see what that looks like. A lot of this is just so that it's easier to see what's going on in the graph. At the end of the year, we're going to have, to analyze more complicated functions, and it will, at certain times, be difficult to tell the functions apart from each other, especially if you don't have color graphing. So this is a technique that can really help out. Now let's say we're interested in that intersection there. Maybe we're not sure it intersects only once. So we're going to zoom in and make sure that it intersects just once. So we put the cursor there, click zoom in, and we can get in real close and make sure that those two functions only intersect each other once. All right, let's go back. We'll zoom. Let me go back to Z standard. Let's see what else we need to talk about here. So a lot more practice with graphing different types of graphs, logarithmic functions, exponential functions, parabolas, different types of polynomials. So that's going to be nice for us to deal with. Let me show you another thing. Let's say that we wanted to shade the or determine the area of intersection between these. Let me rephrase that. Let's say we wanted to determine the area enclosed by these two functions. So looking at the graph of the parabola and the line, we can see that there's a small section right here that's completely enclosed. And we wanted to maybe analyze that. What we could do is we could graph below the line and above the parabola. So we're going to go below the line. So we're going to go down here, and we want this is shade below. And then down here, we want to shade above. So this is shade above. And let's go back and see what that looks like. And then it's giving us a nice visual of the area enclosed between the two functions. This is something that we're going to do a lot in this class towards the end of the year, finding the area of, the area enclosed by two functions. And sometimes it can be very difficult to visualize what that enclosed area is, and this can make it nice and easy. So especially color, very nice. If you've got black and white, it can get a little bit trickier, but you should still be able to see it reasonably well. Okay, so again, we might use these later, so we're not going to clear them, but we'll turn them off. And let's graph something else. We're going to graph the function sine of x divided by x. And remember, when we're graphing trig functions, we need to go to mode and make sure that we're in radians. So we are, so that's good. And let's take a look at this. So we're going to graph that. We're going to go zoom z trig, number 7. And let's see what we've got. Okay. Now, if you're paying attention, you might know why we've picked this function. The value of sine at 0 is 0. And we've got x in the denominator. So in this case, we've got 0 divided by 0. Technically, division by 0 is undefined, and this function has some odd behavior. And this is what I wanted to point out. Sometimes the graph is not enough. Your calculator can oftentimes make a mistake and lie to you, give you something that doesn't work properly. You're going to want to go on to the next video.